Okay, so let's go. I know it's going to be tough because it's kind of late evening. You don't really have the mood to learn mathematics, so no worries, no new topics. But let's do a bit of revision for your class test. Did I mention that you're going to have your class test one next week? Although I didn't mention the date. Did I say that?
You didn't mention the date.
Sir did mention on the class test will be on the second class of
Uh,
next week.
yes. Okay, so second class of next week. I checked our timetable just now. I believe it's on Thursday. Right? From my side, I'm not sure whether the students have already received the timetable, but for the lecturers, I saw that our second class is on Thursday. So most probably it will stick unless the timetable changes suddenly. So today maybe I've actually find three questions, just three. Okay, so three questions for us to do some kind of revision on chapter 1. Not chapter 2 vectors, because your class test 1 will only be on chapter 1, which is multiple integral. You have double integral, you have triple integral, you have polar coordinates. And that, yeah, of course the double integral is a bit much. You have limits of constant, limits of variable, limits over a general region. So I think the constant part and the variable part is not that hard. But general region, maybe. So the three questions we are going to do today is two on general region and one for polar coordinates, and that's that. Okay, so let me share my screen. Okay, let me check. Okay. Let me set it up a bit so that I can see the chat box as well. Okay, so 1, 2, and 3. Three questions. Okay, for the general region, I actually wanted to ask you guys to do this, but then I changed my mind. I'm going to do one of the question. For the second part, which is also against a general region, this I want you guys to try it out. Okay, so because some of you might choose to study at the very last minute, so chances are you haven't even studied for multiple integrals yet. So I want to do a quick recap because before everyone go blur and don't know how you want to answer it. So let's try this out. This is an example. I am sharing my screen, am I? Yes, okay. Back to the question. This is an example of a question where it involves double integral. So as you can see, they gave you an, let me choose. Okay, now they give you an integral, but then the limits are not being told here. It is simply say that you can find the limits by looking at the region R, which is bounded by this equation and this equation, only two equations. So there's no way for you to figure out unless you plot it out. Unless you plot the equation, the one and only way to figure out what are the limits is to plot, and from the plot determine your limit. So I took some time to plot the graph just now. Let me show you. I plot it by using Desmos as usual. So even during your class test, if you come across, I'm not sure because I'm still preparing the class test, but if you come across questions like this, of course you can open Google and use Desmos to plot the graph. Okay, and then do you have to submit the graph? Depends. As I say, I'm still preparing the question, but nevertheless use Desmos to help you find out what is the region. Okay, anyways, these two equations I plotted in Desmos, and this is what I got. Okay, so we have a circle and we have a line, the blue line and the red circle. So I can't scribble on top of Desmos, but the region bounded by the circle and the line is the segment. I hope you can see my cursor here. The segment between the blue line and the red curve here. This is the segment. Okay, so let me minimize that a bit. Yes, okay. Now this is the segment when I plot both of the graphs. So from here, if I want to deduce my x and y, just know that one of the limit is going to be constant, the other limit is going to be variable. It is going to disappear if I click OK. Thought so. For a moment, guys. Okay. So when I look at this, I see that it's easier for me. Okay, it's not compulsory, but I feel it's easier to fix x in terms of constant. So I'm going to fix x in terms of constant. Okay, and I see that x, the bounded region starts from x is equal to 0 and x is equal to 2. So starts from 0, ends at 2. That's how I read it. The y, however, okay, unfortunately I can't scribble on top of decimals, but the y, the way I see it is that you read y from bottom to top. So it starts from the blue line until the red curve, blue line until the red curve, blue line until the red curve. No matter where I look at it, is from the blue line to the red curve. So the blue line just now was this. When I plotted, this was the blue line. This was the red curve. Okay. So let me rewrite this a bit. If I rewrite the whole equation, it will be y is equal to 2 minus x. This one, it would be y is equal to square root of 4 minus x square. Okay, so because the limit is from blue to red, it's going to be from 2 minus x until square root 4 minus x square. This is the hard part. Everything else is just basic integration. The hard part is to find the limit. So if you are done with this, the rest of it is easy. Okay, so once I find the limit, let me just write back the integral here. The integral was, we have a double integral of x square y. Okay, of course the question said dx dy, but based on the limits that I choose, I have to make a decision. Do I want to stick with that or do I want to change the order? I see that y is in terms of variable, so always do the variable first. So meaning that I'm going to do y first and then x. Okay, so my y was 2 minus x to square root 4 minus x square. My x is from 0 to 2. So this is the version of the integral that I'm going to do. So perhaps I change my pen for the solution. Okay. Anyways, from here onwards, it's basic integral, but I'm still going to repeat for the sake of an example. So when you integrate with respect to y, your x is a constant. So meaning that, okay, keep the outer integral remains, but the inner integral, we try to do it, the whole inner integral. So integrate this with respect to y, I'm going to get x square y square over 2. And then, of course, the limits from 2 minus x to square root 4 minus x square. All the other things remains. The dx remains a dx, the outer integral remains outer integral. But the inner part, we solve it. So, okay, I can immediately solve this. I mean, I can put it, but I don't like the over 2 because I think it make the complication a bit. So let me just remove the 1 over 2. It's a constant, so you can remove it. Not necessary, but you can. Okay, you can remove it. So if I bring out the 1 over 2, okay, bring it out outside. So what remains here is a bit easier to handle. X square, y square. Again, not necessary, but I like to do it. Okay, so now let's solve, not solve, but put in the limits. If I put in the limits, I checked just now, okay, I put in and I simplify a bit, I want to save space. The last thing that I get once I put y is equal to this minus y is equal to this is that I got a 4x cubed minus 2x to the power of 4. Okay, of course there's a few steps involved. I put in the square root, I put in the 2 minus x, put it into y. Don't accidentally put it into x. You integrated recently with respect to y. So your limits are limits for y. Okay, make sure you're alert on that. Okay, running out of page. Let's go up. So from here, if I further integrate, it's going to be power 4 divided by 4. So it's just x to the power of 4. This one is going to be 2x to the power of 5 over 5. And the limits are 0 to 1. Sorry, 0 to 2, isn't it? Why did I put 1 here? 0 to 2. So if you put 0 to 2, what I got just now was, here I got a 16 and here I got 64 over 5. So my final answer was 8 over 5. I don't think this red part is your issue really. Okay, it's just basic integral. But the hard part here is to get the limits. That is the harder part here. Okay, I hope you can follow along. It's okay if you did not write this down. I will share the PDF file anyways with you. But remember the step. The first step is to find the limits, the hard part. The second part is to actually solve the integral. Do the inner part first and then the outer part. Okay, so let's keep that in mind, these two steps. Okay, I'm so sorry, I'm just looking at the chat, was so occupied doing this thing. Anyways, the only one question is, can we use Desmos? Yes, as I said just now, you can. Okay, you can use Desmos. Anyways, let's scroll down to one question where I want you guys to do it. Okay, simple steps, similar to just now. Try this out and I will share the answer in a while, very quickly. Anyone who gets the final answer first, please let me know in the chat box. Correct or wrong, that's a different matter, but try it out, and if you get a final answer, immediately let me know. For a while, guys, I think I'm hearing something, some noises, not sure. Let me just mute all, just to be sure. Okay, but if you have any question, you can unmute and ask, of course. Lim, you shared a graph. Do you want me to check whether your graph is correct or not? I mean, if you plot the two, how many? 1, 2, 3, obviously you get that graph. So yes, that should be correct. So the bounded region is a small thing there. It's a small shaded region there between the curve. It looks like a slice of pizza here. That should be the region. Right, good Dinesh, you got the same graph. So did you manage to figure out what are the limits from the graph there? Can we divide into two regions? Yes, if you want to. Come on, Dinesh. Lim, you can. I think the reason why you are asking that is because are you fixing y in terms of constant? Maybe. I think that's the reason why you ask. Anyways, you can do that. This question is solvable by not separating it into two parts. But if you want to separate it, it's not wrong anyways. Okay. If you do want to separate it to be y as a constant, then yes, the only way to proceed is by separating it into two regions. But if you fix x, you don't have to. Okay, is the final answer 106 over 15? Let me see if that can be simplified further. I got a different answer, but let me check whether they are actually equivalent. Okay, here's the deal. When I tried it out, I got 7 over 15 just now, but I didn't even double check. I get 7 over 15. That is what I got. So how about the others? Did you get the same answer as Lee got here? Okay, so I do have a 7 over 15. Okay, 7 over 15 then. So Lee, I think something went wrong. At least you already get an over 15, but the 7, you got something else. So while you guys are doing it, let me just write it, my solution here. The graph is as who uploaded just now, as Lim uploaded just now. So from there, I actually deduce, I fix my x to be a constant. Okay, some of you might do the y to be a constant, up to you. But when I fix x to be a constant, this is what I got. So which means because this is my limit, I did my integration something like this. I see that the graph is 1, right? Yes, the intersection point ends at 1. Correct. So differentiate x with respect to y, we'll get xy. Sorry, integrate. Accidentally said differentiate. I put in the values, I simplified, and I got 2x minus x squared minus x to the power of 4. Okay, so those who did x as a constant should have gotten something like mine. Any of you, if you have trouble understanding what I'm explaining in front here, let me know. Otherwise, I'm assuming that you can do it. It's just that you have nothing to ask. Okay, good Arish. Good that you get it. This integral was a bit more easier compared to this one. This one was slightly more complicated. So make sure everyone, you should get 7/15 no matter whether you fix x or y to be constant, doesn't matter. Okay, the execution might be a bit different, but the final answer should be the same because the order of integration doesn't affect the integral you are getting. Okay, so let's move on. Please stop me if you have any question. Otherwise, I'm going to move on to one final question for today. Slightly longer, of course. Polar coordinates. Okay, yeah. Okay, so this is an instance where it already is mentioned in the question that you must transform to polar coordinates before solving it. I'm not saying that the only way to do it is by transforming it by using polar coordinate. Maybe you plot the equation given here, you can describe it in terms of x and y, maybe. But if it is already mentioned that use polar coordinates, then of course use it, because that is what the question want to test you. So although you get the final answer, but if you didn't change it to polar coordinates, you are doing in a way that is not required by the question. Okay, so be a bit cautious on this. If it is not mentioned, up to you. If it is already mentioned, make sure you convert it into polar coordinates. So only one equation, a so-called disk, right, is given here. So I'm just going to take the whole thing and plot it. I got something like, for a moment, wait a second, where is the zoom button? Okay, so I got it something like this. Okay, this is the equation that I plot. It's shaded, but it doesn't matter. What we are dealing with is a circle, the whole circle. No, not portion of circle, the whole circle in this case. This is not always the case, okay? Sometimes it will only be a certain part of the circle, like the first quadrant or the second quadrant, or maybe a slice of a circle. It is possible. So you have to do more questions to get to know how to describe different portions of circle by using polar coordinates. But in this case, we just close the other two graphs. Okay, for this case, we are dealing with a whole circle. And I'm not going to use x or y. I'm going to use polar coordinates. Okay. For those in the chat box, bear for a moment. I'm going to push this to the other side so I won't be able to see the chat. Just until I get the limits. Then I'll move this away. Okay. So. Alright. This doesn't matter. Anyway, so polar coordinate means describing a region by using radius and angle. Keep that in mind. Polar coordinate means using, where do I have okay, radius and theta. Theta is the angle of the whole rotation, starting from this line. Okay, it's from the first quadrant until it rotates, until it completes a whole circle. Sometimes it doesn't complete, maybe it's only halfway, but in this case it's a complete circle. Anyways, so in this case, my radius, the smallest radius that can happen is at the very center here. It's just a dot. A dot, as in there's no even radius, it's 0. The biggest radius I can get is when I go to the whole circle, the full circle. So from here to here, the biggest radius possible, the length here is pi. It's not a nice number, but it's pi, okay? So that's why my radius is from 0 to pi. Then my theta, the smallest theta is when it is about to start, haven't moved yet, it's at the quadrant, so it's 0. And the biggest angle I can get is when it's complete the whole circle. So when it completes the whole circle, it's 2 pi. 300 degrees, but don't write 360 here, put 2 pi. Okay, so that's that. Is there anything else to describe it by using polar coordinates? No, that's that. So because of this, I'm going to change the whole equation into r and theta. Doesn't make sense for me to have x and y, right? Because now my limits are not x and y, they are r and theta. So in order to change this, we have a few identities or few equations. We have x is equal to r cos theta, so you can use this. We have y is equal to r sine theta, you can use this. Or we have x square plus y square is equal to r square. And do we have anything else? Yes, another thing that you should know is that when you change dy dx, into dr d theta, you must always multiply an r. Okay, a standard procedure. So these are the things we have. I can take the long way. I can put my x here to be r cos theta. I can put my y here to be r sin theta. I will still get the answer. But I don't want to use that because I already have something for the whole x square plus y square. X square plus y square is equal to r square. So I can just use that. Okay, if I use that, then the whole integral will become sine is sine. There's nothing much I can do. X square plus y square is equal to r square. Square root of r square is r. Okay, so but let me just write square root of r square so that you don't miss out anything. And then the dx over dx dy, if I want to change it to dr d theta, I have to multiply an r. Okay, of course it can be d theta dr as well, but out of preference I choose dr over d theta. So it's from 0 to pi. My theta is from 0 to 2 pi. Okay, so there you go. This is your integral. So, okay, before I solve this, try this out. Try to solve it. What is the final answer that you can get? Just try it out. In a few more minutes, I will show you how to do it myself. Let me see the chat box. Okay, Lim has already shared the circle actually. Should we change the grid? Oh, do you mean by the grid from Cartesian grid to polar grid? It's up to you. For me, I just plot the Desmos to see the shape of the graph. And then once I get the graph, I just maybe sketch back the circle on a piece of paper and then look what is happening, and then from there I get my limits. But if you think changing the grid from Cartesian to polar helps you out, go for it. Whatever that helps you to get the limit.
Sir,
Yes.
can the square root r square I like change to r?
Yes,
I
yes,
multi.
correct.
Okay, okay.
Okay, just as a disclaimer here, if you cancel off the square root and r squared, it becomes sine r, right? But then you don't multiply with the r to become sine r square. No. Okay, the sine r is a term, r is a term. So they are two different terms. It doesn't become sine r square. Just want to remind you in case if you do any mistakes. The r is being multiplied to the whole term. Maybe if I put a bracket, it will be more clear. The answer, Felix, what did I get just now? I got a 2 pi square. 2 pi square. That is what I got. The r sine r, there's no easy way to integrate it, right? No. I think the only possible way to integrate it is by using integration by part, where you choose a u, you choose a dv. I hope you still remember it, because it's a r and sine r. The only way to proceed is by part. So if I use integration by part, this is what I would choose to be my u, and this is what I would choose to be my dv. So once you have identified your u, you have already know what is your dv. There will be four things that you will know. You will know what is your you will know what is your u, you will know what is your du, you will know what is your dv, you will know what is your v. So there are four things. So once you know these four things, then integration by part is simply uv minus integrate v du. Okay, so this is integration by part. The answer is 2 pi square. Yes, yes, Brooklyn, that is correct. That is 2 pi square. So you did get it. Okay, nice, nice. How about the others? Did you get the same thing? It should be 2 pi square. So let me just proceed with one more line, those who are stuck from this part. So the whole inner part will become okay, so I just did the inner part. It becomes uv minus integrate v du. So I can simplify this a bit. I can actually solve this integral furthermore. Integrate negative cos. If you manage to get until this part, once you substitute, you put in your pi and you put in your 0, right? I did realize that when I compute, the whole thing just simplifies into pi. That's it. I did not get anything apart from pi. Yeah, so I only got pi. So make sure that when you compute sine pi, for example, don't put in your calculator sine pi. You must change the pi into degree first. So it should be sine 180. Okay, that should be the correct way to, unless some calculators you can change the setting to be radian. So either you do that or you change it to degree first before you put it in. You want me to substitute in and simplify it? Is that it, Anish? Okay. The reason actually why I stopped is I couldn't scroll my PDF anymore. I should have allocated more space. Okay. Let me think about it. Okay, let me just write down here. Try to squeeze in something. Okay, so here we go. I put in my R to be pi. Okay. If I put in 0, negative 0, the whole thing becomes 0. So that's it. No need to do anything. Can I write it as R square cos? No, you can't. The reason is because cos on its own has no value. Just cos, there's no value. This is actually cos R, one term, and R, another term outside it. So that R and the R inside it cannot be combined. Otherwise, it doesn't make sense mathematically. What's the value of cos? Cos is nothing. Cos 10, cos R, cos X, that makes sense. But just cos, that's just a letter. There's no meaning to it. Okay, so I put in pi minus negative sign 0. So minus and minus becomes plus. Hey, sorry. Okay. Yep, so this is what I get. So cos pi is negative 1. Sine pi is 0. Sine of 180 is 0. Sine of 0 is 0. So yeah, so the only thing that you have is a negative pi times negative 1, which you get only positive pi here. If I want to be really complete, I should include this just now. It's a minus 0. Tanish, as for the substitution, is it a bit clear now, Tanish, on how to substitute? Let me know if it is still confusing. Okay, all right. Good that you get it. The others, make sure that you understand the substitution as well. So of course, again, I did not put cos pi into my calculator. I put cos 180 because pi is equal to 180. So if you get weird pi, just remember that from radian, if you want to change to degree, you have to multiply 180 divide by pi. That's the process. This is how you change from radian to degree. So yes, no worries if you haven't copied down whatever that I wrote here. I will be sharing the PDF right after class. So do any of you have any questions before I end the class? Let me know in the chat, or you can unmute your mic, whichever it works. What on earth is that, Hugh and Long? Will triple integral be included in the class test? Yes, possible. But triple integral definitely won't involve what do you call general regions like this. Because triple integral, if you plot the general region, it will be a 3D object. So of course it exists, but I did not cover in class because for me it's a bit advanced level. So triple integrals might come, but not in this form right here. No worries, I definitely think that it is doable for all of you. Okay, so it's a beautiful 6:14, 1 more minute to 6:15. Let me, while looking at the chat, let me just show you the QR code. We will not need graph for triple integration. Yup, you will not need graph for triple integration, no. But bear in mind, when you go to real life work one day, you might be dealing with triple integrals or maybe more, depending on whatever field you are working on. But for the sake of class test, no, you do not need graph for any triple integration. Okay. Oops. Okay, I did something. Okay. So let me give you a QR code for your attendance. Just wait a minute.
Sir, for
Yes.
the graph part, do we need to draw a graph and then take a picture and send to you?
Okay, I'm not sure because I haven't finalized the question, but if you are required to put in the graph, I will make sure that I will state very clearly in the question, include your graph. If I did not say that, then you don't have to. Okay, it won't be confusing. I will mention clearly in the question what you need to do. So if it's no mention about graph, then you don't have to. Okay, you don't have to send it to me.
Can we freehand draw the graph paper then?
Yes, you can. Desmos is just to help you out. If you want to draw it on a piece of paper, go for it. No problem with that. All right, there you go. Yes, Abdullah, there is an exact date. I checked my timetable just now. Our second class is on 16. Is it the 16? Today it's 10. Yes, it's a 16. So 16th of July, a beautiful Thursday it is. Unless the timetable changes, then I'm not sure. But so far, according to the timetable, Thursday we are having a second class. So our class test would be at that time. Okay, how many more here? 3 absent. Not sure whether absent or having technical difficulties. I will download the attendance sheet from Teams anyway, so if it's technical difficulties, make sure you let me know. Alright, so that's that. 6:17, let's end our class. If you have any question after this, just ask me in chat box. Yup, correct, just chapter 1, just chapter 1. Okay, you're welcome. Bye.
Thank you, sir.
Alright,
Bye, sir.
Bye,
Bye.
sir.
bye-bye.
Bye, sir.
Thank you, sir.
Welcome.
Adios, sir.
Adios.